A semiconductor chip is a tiny piece of silicon that contains millions or even billions of microscopic transistors interconnected by multiple layers of metal wires. All through it appears as a small black package from the outside. Inside, it is a highly organized electronic system designed to process, store, and transmit digital information. Every organization is performed by a smartphone, computer, networking device, or embedded system begins with electrical signals entering the chip through its input pins. These signals are interpreted as binary values, zeros and ones, based on voltage levels. Power of supply to the chip enables the transistors to switch between on and off states, forming the foundation of all digital computations. At the heart of the chip are MOSFET transistors, which act as extremely small and fast electronic switches. When a transistor is turned on, it allows current to flow, representing one logic state, and when it is off, it blocks current, representing the other logic state. Individually, a transistor performs only a simple switching function, but billions of them connected together to create complex digital circuits. These transistors are arranged into logical gates such as AND or NOT and NAND nor XOR gates, which perform fundamental Boolean operations. By combining these logic gates, engineers build larger functional blocks such as adders, multipliers, comparators, multiplexers, encoders, decoders, and ALUs, enabling the chip to perform calculations, make decisions, and process large amount of data at extremely high speeds. A semiconductor chip also contains sequential logic elements such as flip-flops, registers, counters, and FSMs that allow it to store information temporarily and remember previous operations. Unlike combinational logic, whose output depends only on the current inputs, sequential logic depends on both the current input and previously stored data. The operation of these storage elements is synchronized by a clock signal which generates regular timing pulses throughout the chip. At every clock edge, data is captured, processed, and transferred to the next stage to the circuit, ensuring that billions of operations occur in precise and coordinate sequence. Modern processors operate at clock frequency of several gigahertz, meaning billions of these synchronized operations occur every second. Communication inside the chip takes place through an intricate network of microscopic metal interconnects speed across multiple layers above the silicon. These interconnects carry data signals, address signals, clock signals, control signals, power, and ground between different functional blocks. Along the logic circuits, chips also include various types of memory such as registers, SRAM, cache, memory, ROM, FIFOs, and buffers which store instruction, intermediate data, and frequently accessed information depending on the application. Additional specialized hardware blocks such as CPU cores, GPU, AI accelerators, memory controllers, Ethernet MAC controllers, PCIe interfaces, USB controllers, display engines, and security modules work together to perform dedicated tasks efficiently. Every time a transistor switch between on and off, it consumes a small amount of electrical energy since billions of transistors switch continuously during operation. The chip generates heat, making efficient power management and cooling essential. Modern chips use techniques such as clock gating, power gating, dynamic voltage scaling, and frequency scaling to reduce power consumption while maintaining performance. Finally, after processing incoming information, the chip sends resulting data through its output pins to memory, storage device, displays, communication interface, or other electronic components In essence, a semiconductor chip is a highly integrated microchip system where billions of transistors synchronized by a clock and connected through a interconnect wiring work together to execute instruction, processes data, store information, and enable the intelligent operation of modern electronic devices.